That's so weird. I hope that doesn't happen again. I feel like it's only because my computer went to sleep or something. Um, is there a Power Toys? Awake. That's so sick. Power Toys is dope. Okay, whatever. So presumably now my computer will not sleep if that was the issue. Okay. Okay. All right. So here's shit. Okay. So since I'm probably not gonna upload that former stream because it was nothing, here's what we got. I'm back from backpacking. 3 nights in Northern California. Very beautiful. We got two of these, two high RPM DC motors. We have a dual motor drive. Okay. We broke the Pico on this thing by removing power to one of the motor drivers, and somehow that like busted my Pico. I don't really know how that happened. So I just soldered the headers onto this new Pico. I bought more Picos because this is my last one, and if I bust this, I'm sort of shit out of luck. Um, oh yeah, I bought Nerf rival rounds, and so we're gonna be designing in CAD basically a flywheel mechanism where we're gonna have two of these here and a wheel spinning, opposite directions. And when you feed in one of these rounds, it's going to shoot it forward. Okay, so let's just get started. Oh yeah, I forgot to look for higher gauge wire for the power. Oh yeah, and I forgot. And then I have a 20 amp power supply at 12 volts, which is what the motors take. Um. Okay, so let's try to get one of these spinning. Out one and out two. Okay, so let's see. I think that it doesn't matter. I think that these um okay, so yeah, so I'm definitely gonna need um you know what? I haven't done this in a long time. I'm gonna get because I love when I speed up my footage and I see me putting together the thing. So I'm gonna get my little brick stand thing and some tape and my webcam, and then I'm gonna put it together so that at least somehow documented, even if you can't see it all that well. Um, yeah, and then oh wait, but I actually have 10 amp fuses, so maybe I could get those 10 amp fuses. Might as well. I would hate to break anything. Oh yeah, and the kilowatt. Okay. So I went out and splurged, and I bought a professional camera stand. These are things I don't know. I can't believe I thought I... Okay. Hajimete, hajimete, konnichiwa. Okay. I gotta get kilowatt. All right. Kilowatt. There's so much setup when you have to actually do the building and assembly and testing and stuff like that. So yeah, so this, I might as well just handle this. 1, 2, 3, 4. One, two, three, 4. Okay. So now the motors. I just want to resolve this so that I don't forget, because this little thing is. Oh yeah. Wait, I want to scratch this. Let's see, what's hard? Whatever, it's good enough, I think. Let's see. Oh yeah, that's plenty. Perfect. Upgrade, upgrade. This is gonna save me so much nonsense. Um, can I use the pliers? Oh yeah, there we go. Use physics. Use physics, bro. Oh, yeah, that's plenty. Okay, so all right. So now, okay, that little change was just I have these motors and they have female connectors on them, but I need male connectors to plug into my breadboard. So instead of having these wires that are all differently sized and shit, where I put on the headers and that'll be easy to connect. So that's just a small fix that'll make my life a whole lot easier when I'm connecting up the motors. Okay, so the next thing is um, oh yeah, is I need female to male breadboard wires to connect from this board. So wait, why don't we just set this up? Okay, so here's what we want to do. Do I need tape? I probably do need the tape. Okay. And then what we need to do. It's around here, and then gotta get this as close as possible so that it looks like it's vertical. I used to have like a tripod that I did, but okay, that's good. But we need tape. Okay, so I need to get tape and I need to get those wires. Oh, come on, bro! I knew that was gonna happen someday. Spilled this Yaffe, bro. Spilled the freaking Yaffe all over the freaking grisound. The biggest L of that is the tape, bro, or is the ice. I'm a dummy, bro. What the fuck? Okay. Okay. New coffee. Putting it in a safe location. And then the jumper wires. And then I don't know why my camera is all messed up. Maybe we do want tape. Okay, I'm gonna go get the tape then. So wait, let's just fix this. Okay. And then a little bit. Okay. Wait, did this? Okay, yeah, we're good. Where do I want to do this? That. Okay. That's not going anywhere. Okay. All right, so let's set this thing up. We'll probably make this full. Okay. So we got our Pico, this kilowatt. I literally almost knocked over the coffee again. That's insane. What is wrong with me, bro? What is wrong with me? Okay. See, I would use a thermos, but a glass with ice in it is just so pleasing. Okay. How'd this get so low? Hello. Test. Yo. Test. All right. Okay, so okay. Where's my data sheet? Okay, so let's see if you can see this. This is the data sheet. So basically, okay. The first thing we need to do is we're just trying to do one motor. Okay, so we need to find 5 of these. Okay, 1, 2, 3, 4, Okay. Beautiful. So let's just do it. So red will be plus 5 volts. Enable will be purple because that's the pulse width. P for pulse. Okay. In one can be blue. In two will be yellow. Oh, and ground. Let's see if I can find a black one actually. And then how are we gonna ground this thing? We're gonna need a ground for sure. Okay. And then okay. Oh, and I forgot to get the high gauge wire. So we'll need to do that. So see if we can find a black one. So the reason why we don't need the big gauge on this is that it's just for signal. So it's like not really important. Oh, perfect. Oh wait, this is not right. Never a waste of my time. Whatever, I'll just add a little thing. Caught it when I'm burning. I might quit. Okay, that's ground. So let's just do it. Ground. And then at no point is so the ground. Okay, so I'm pretty sure what I need to do is tie ground to one of the. So on this thing, there's 3 comms and a ground. I think I need to tie ground to comm or something, and then tie ground also to the breadboard. But I don't want any of the V's to be going to the breadboard because I can't run 20 amps through a breadboard, almost certainly. So, but I do want to make sure that my ground is common to everything. Okay, so then in one, we'll just make that. So let's look up the Pico W pinout. Okay. All right, so so in one will be GP0. Let's just do that. Pin 1. It's easy to remember. Wait, this is in 2. So okay, so that like that. This is PWM. So this will be okay, wait, let's shift this down then. So PWM is going to be pin GP pin 2, which is actually pin 4. 4, 5, 6. Okay, now they're all tied next to each other. And the reason why because we want to test the reversal. And the thing is, you're not allowed to reverse it quickly. You have to do a break for more than 0.1 seconds. Okay, and then this is power. And so this is 3v3 out, which is 36. So 36 is the 5th one down. Okay, cool. So that's all hooked up. And then we need a little jumper for ground. I thought I had some of these, but we'll make more. Okay, I'll just make more. Ay, ay, ay. Okay. Hajimete. Hajimete. But I don't even know what I'm saying. Konnichiwa. Okay. Pin 38. Is ground. Okay. Now we need a longer one. Damn. There's people that make their jumpers like perfectly sized. I have so much. I'm jealous of their patience. I cannot do that. Okay, so now we have a common ground for the Pico and the motor driver. But what we need. Okay, yeah. And then the bottom one is the ground here. We don't want to fuck that up for sure. That will definitely destroy it. Okay, I think I'm gonna ask ChatGPT what to do. Okay, so what was that? Why the game was messed up? Um, I have a 12 volt, 20 amp power supply that has LN ground 3 COM 3 V plus and plus V edge. I'm going to be hooking this up to a dual motor driver, but I want to make sure I have a common ground. With my Pico W. Should I tie ground to one of the COM and then the COM to the blue minus rail on my breadboard, which okay, yeah, I mean that's what I did for my benchtop power supply, so I didn't see why it would be any different. Presumably, all of the COM and all the V plus, all the COM on the are tied together internally. Okay, cool. So Oh, there we go. Okay, so we need to get some thick wire. And then, okay. How much current can go through breadboards to a typical... Oh my gosh. Yeah, but so what am I trying to think about? It's like, okay, if, but it should be fine to have COM go to breadboard. Yeah, okay. Do I unscrew this thing? How do I get to it? Okay, so let me find some red and black high gauge wire. Yeah, let me just go do that. Okay. So so I found this, which is pretty thick stuff. But then I realized that the comb. Oh, and damn it, I forgot that I have to tie the comb together. Maybe I'll just use that one. And then let's see if this goes into the breadboard. Not really. I don't want to stretch that out. The annoying thing is that this cable. Oh, you know what I could do actually? I could grab a different one. Okay. I could grab one of those 3 prongs because I have like a million of those. Strip that. Okay. I don't know if there's a polarity to it, but we'll see. Okay. So, but the cable that goes to my computer to the wall is not 3 prong. So even though I have this, which is a cable that goes to there, which is presumably better. Um, so we still need a way to close the ground. Um, so wait, so okay. Right, but ground is not necessarily tied to calm. Okay, so let me get my screwdriver. We are slowly but surely getting there. Okay, so I actually want to take a picture. Can you tell what color that is? That's blue. Okay. The N is blue. Oops. Yoink. Okay. Now, let's move this out of the way. Okay, so we're just going to do the exact same thing. Okay. I have a three-prong. I have a three-prong wall outlet, and the colors are blue, brown, and yellow with a green stripe. Which go to which on my power supply? Blue is neutral. Brown is live. Okay, and yellow is ground. Okay, cool. So just twist them up. Make sure they're there. Good. Okay. Blue is neutral. So let's. Oh, actually, how do you do this? You're supposed to wrap it around, probably. Do they all come all the way out? So. Okay, you want as much contact as possible. Okay, okay. Whatever, I'm just gonna do it straight on. I need to cut more of this. Just a little bit more. Come on. Okay, got. There we go. Okay. All right, that's better. Get this guy in there. Okay. Cool. Now brown is live. And yellow is ground. Now, the thing about the ground is we're going to need to put two things in here. So why don't I just get that ready? Where did I put that? We have this one and this one, but then we had a third. Is it this? No. No. Oh, here it is. Okay. So I think what I'm going to do. Should I be maybe better safe than sorry, and I'll just use the thickest one. Just in case. So I'll cut off probably like that much. And this is probably, I probably need to get different wire strippers. Okay. Okay, so now we're just going to bend this. And it's going to go into both of them. So let me just finish this. And then yeah, this is really thick stuff. This is great. Oh shit. Let's crimp it a little bit. Okay. Cool. That's great. Yeah. Oh. Okay, that's in there. That's tight enough. Definitely making contact. Okay, so now we're going to use these two. Or no, we're going to use, let's see, COM should be just a normal 22 gauge wire, so it's tiny. But then red, let's see. We're getting close to testing this thing, which is very nerve-wracking, honestly. I don't like how much is exposed. See if I can get it any further. See, am I even getting any of this? No. Okay, so we're gonna try to keep this twisted. Get it in there. Yeah, it just doesn't go that deep, so I'm just gonna cut some off of it. Okay, because I don't want to short anything. So, okay, that's nice. Nice and tight. Ooh, this thing is pretty weak, actually. This terminal block can't take any force at all. Okay, that's definitely good enough. Okay, now we're just going to take the first V plus. Put it in there. Okay. Now we just need calm. I think I'm just gonna do this. This is the most sus part of the whole thing. Is using this wire as opposed to because this isn't even copper. This is like some alloy or some. What is it made of? Let's see. Does it say? I don't know. Okay. Oh, but you know what? Maybe I'll use. Maybe I'll use the third comm with the thick wire. Better safe than sorry, right? Because then, yeah, I'm going to do that. So wait, so let's strip a small amount off of this thing. And they're all tied together, so we really shouldn't have an issue. Get in there, bastard. This wire is actually too thick almost. I think I'm just going to cut off this knot. Did I put it in the wrong way? There we go. Let's see. Okay, let's see if this goes in. Okay, that goes in. So then maybe. What if I just use. There we go. Okay, so we're basically ready to test this thing, which is scary as hell, to be honest. Um, what the fuck? Okay, so now I'm just gonna flash it. Oh yeah, and now we need more high high current wire because and then actually I'm gonna get one of those 10 amp fuses. So if we look at the example circuit, it recommends putting a 10 amp fuse to the motor. And actually, we're going to be building this one, but it's still recommends a 10 amp fuse. I don't understand what this schematic right here means. But regardless, okay, so the first thing I want to do is break. So what does this mean? 0 is low, 1 is high, X is any level when floating high. What does that even mean? Okay, and then also, I don't want to solder to this yet because I don't. Oh, but you know what? It came with some like crimp connectors, which I've never used before. But the thing is, I don't know if crimp connectors are removable or what. I've never done this before. But so it came with these plastic things. Whatever. They have this at the end. But then it also came with a bunch of these, which are metal, and they slot over. You take one of the tabs, and it slots over it. Oh, you know what? That's probably. But once you crimp it, can you get it off? Because I would really. I mean, who would design it so that you have to solder to it? That's like total bogus. But then we do need some thick wire to slot in there. Presumably that's conductive. That's um and then um I also want to ask okay, if the polarity of the DC motor matters. I think it doesn't cuz there's nothing on here that indicates what's plus and what's minus. I think there's this red one here. Okay, oh yeah, and let me show the. So this is what the power supply looks like. We got neutral, live, ground also tied to COM, then a COM that goes to the breadboard, and then a COM that goes directly to the motor driver that's high gauge. And then V plus, which goes directly to the motor driver as well. Let's see, is there downloads for this? It's crazy that. Oh yeah, was I gonna get the fuses? And then is there a switch on this thing or what? There's no switch on this. I feel like that's weird. Okay. Okay, yeah, these are definitely not brushless motors. I feel like I was suspect of that when I moved it and I heard a little sound. But then I looked at the Amazon reviews and they also said, yeah, these are not brushless. Not at all. Um, and there is a polarity. This red thing is the positive side. Um, Now the question is whether or not I can get this thing to work, or if this motor driver. Okay, so yeah. Okay, so okay, yeah, it probably is a brushed motor, uh, and the advertising was just false. But does that mean I have this dual motor driver that has two outputs, and presumably I can use this thing to drive my brushed DC motor, right? Okay, fine. So be it. I'm gonna go get some more wire. And you know what? I could cannibalize. I mean, it's good to know that like because we have literally thousands of these. This is the cable that we have the most of. Is these either two or three prong wall plugs, and since it goes to the wall, it probably is designed to handle pretty high current. Oh, jeez. So that's good news. Is that I could just use this. It actually is not that thick of wire. Maybe I'll go get a different one. And we have so many of them. Well, I could bring the red spool up. Okay, so here's. Okay, let's just get this working. I'm being such a bitch. I feel like it's so easy to just get nervous and like not want to break things, but at some point, as long as you've done the due diligence, you might as well. Oh, and is this shielding? Is that how that works? How does this work? You put this in there. Okay, yeah. And then you put the wire in there. I don't know what the screws are for. I guess the screws are mounting screws. Yeah, and it doesn't come with nuts. That's right. Okay, fair enough. Okay, then you crimp it down, and then you crimp that down. That's how it goes. Okay, I'm gonna go get another one of those wall plugs that's a little bit thicker. Okay, and then we're just gonna send it. I'm kind of nervous, man, because let me look at that paper again. Okay, let's freaking do this thing. I'm getting more wire. Okay, I probably should have gotten a knife too. Um. Okay, so let's just do this thing. We're gonna use the. Okay, let me get an X-Acto knife and extract some of this. I found a really nice one that has already pre-soldered ends. Um. Okay, so give me a sec. Ever since that end thing, I'm kind of worried that Hey, what's going on, bro? I am building. Well, okay, here, I'll contextualize it. I'm building a robot that shoots paintballs and it's going to paint a painting. But we're sort of pretty early in that process. So the first real thing that was built that came out of this, hold on, give me a moment. Untangle this thing. Is this. It is a basically a turret, so it can like turn this way and it can turn this way. And it'll hold a phone, it'll track my face and stuff like that. But we're sort of moving on to the second real part of the assembly, and that is using DC motors to create like two spinning wheels that if you put a ball like this into the wheels that they're spinning in opposite directions, it'll shoot it forward. And so the idea is that you cover this in paint, you put it in there, and it hits a canvas, and it'll deposit some paint onto the canvas. So, so that's the goal. This is okay. Let's see if that's enough. This blade is kind of dull. Okay, let's see if we can tear it out. Oh wait, there is that stuff that I think you can use to cut it. I think you can use this stuff to cut. No. What are the components that I'm using? So we have this dual motor driver that I have yet to. This is the first time I'm using it. Then the main brain of everything is a Raspberry Pi Pico W. So now I'm getting off of Arduino. I think Arduino kind of stinks. I much prefer MicroPython. I think you can actually run MicroPython on Arduinos and ATmegas, but the thing is they just have no. I mean, they're just like the clock speed is like 16 megahertz. It's like, what the heck? Okay, so this is not going how I wanted it to go. Oh, you know what I could do? I could just cut this and slide it off, I think. So it's not Python, it's MicroPython, which is like basically Python, except it compiles into, the native, is at least is my understanding, it compiles into native, oh, fuck, I nicked it. Damn it. I'll just put some electrical tape over it. Then I don't have to worry. Okay. What's use case? The robot? It's freaking rad as hell, bro. That's the use case. It's freaking cool. Okay. So we're gonna use these two. Let's see, how long do I want to make it? I kind of want to make it long, so I'm gonna cut some more. Maybe that long. Okay, maybe this is good enough. Okay. Yeah, this is good enough. All right, let's cut these. Okay. Now I just need black and white. Out of black and white, what is... I have a black and... Well, ground is black, so I'll make ground negative. So we'll make white plus. Okay, so this is... I don't know what the gauge of this is. Okay. Where's my screwdriver? Always losing tools, bro. Okay, so plus is going to be out 1. Right, let's get this in frame. Okay, so this one's plus. So I've never done this before, but this is like a crimp connector or something. So I'm going to put it in this plastic thing. It's going to slot in. And then I'm just going to crimp it down, basically. And then you crimp that. I honestly don't know if this is right. This seems kind of sus. But, whatever. This is what it looks like. Can't really tell. I hate how this thing focuses. Okay, so now we just need this. And then we need another one of these. Okay, that's good. Okay. Kind of the moment of truth almost. We're gonna see, man. We're gonna see. I've never done this before. Oh, should I get the fuse? Let me go get a fuse and just see. Okay, this is the fuse. I've never done that, but like, I don't even get how you solder onto this thing. How do you even connect to this? Do you take it off? I don't think you do. It's like, then how do you even use this thing? Well, whatever. I'm gonna keep this around. Um. All right. Oh, I think you crimp the other way. I think you're supposed to crimp like this. I don't think it's really on there, man. This one's much better than this one. But I do want it shielded. It's such a loose connection. There we go. That's a little bit stronger. I feel like that should be okay. All right. So, oh shit. So now we need to write some code. Okay. Okay, so the code is going to be just okay. So the code is just going to be writing the right pins to 1 and 0, because the first thing that we're going to do is we're just going to break. So if we see this chart again that I okay, so break is if you set in 1 to 0, in 2 to 0, and enable 1 to whatever, it will break the motor. It'll like prevent it from moving. So we want to see this thing lock up so that I can't turn it. Okay. And then I want to double check. It does say control signal voltage DC 3 volts to 6.5. Plus 5 volts can be connected to 5 volts or 3.3 volts to provide power for the signal slide. Okay. Okay, so we're just going to break it. So okay. So let's just do this. Okay. The board is flashed. I want to just do blink, which Pico W blink. Okay, so we want that extension. Micro Pico, yeah, that's what it is. Okay, so we're gonna run that. Okay, blink is working, so that means that that's good. Stop that. Okay. So this is gonna be okay. Okay, so I have my Pico W connected to wait. To my motor driver where Um, Hold on, let me do this. I have my Pico W, where the um, the enable pin for output. This is all for output 1. The enable pin is hooked up to GP2 on my Pico. The in one is hooked up to GP3. The oh, the in one pin is hooked up to GP3, and the in two is hooked up to GP4. Now write a simple MicroPython code for my Pico um, that that does break, that locks the motor. Oh wait, it's locked right now? No. No, see, it did it wrong. But that's okay. We'll just edit the code. Brake motor is 0, 0. Anyway, is it 3 and 4? Is that right? I think that's wrong. Enable is hooked up to. Oh no, yeah, okay. Enable is hooked up to 2. Yeah, the 0 indexing is very goofy. Okay, now we're gonna. Wait, but we need power. Holy hell. Okay. You pray to the maker gods in moments like this that nothing goes horribly wrong. Well, fear is the mind killer, bro. Fear is the mind killer. We're not gonna play. So, hold on. So, wait. Why don't I. Why don't I unplug the actual outputs from the power supply, get my voltmeter, and then test? I feel like that is a sane intermediate step before I actually do this thing. Okay. Okay. So okay. Okay, so can we see that? Is it even visible? Okay. I can't see that. I need to look at it myself. Okay. Let's plug it in. Okay, so the power supply should be on. Okay, I just heard the fan boot, so that's good. And we're getting 12 volts. Perfect. Okay, so this thing does what it's supposed to do, so it's working, presumably. Okay, so now I'm going to turn it off. Okay, and we are going to... There's probably some capacitors that need a discharge. Yeah. Yeah, there's big caps on there. Okay. Okay. Bro, why is this so nerve-wracking? Okay, so we're going to upload the code. We are going to run this code. Motors locked, brake. Oh, wait. Let's do this. Oops. All right. This is the moment of truth. Okay, I flipped it. Damn it. It's not. Should I set? Let me set the enable pin to something. Let me set enable to 1. It says it can be anything, though. That's why I'm kind of annoyed. Um. 1, 0. Oh, shit. Well, that works. That's sick. All right. Holy shit. Did you guys see that jump, dude? Oh, my God. All right. Cool. Good shit. So I don't know. I guess brake doesn't really lock it up as like I thought it would. All right. So that's so sick. All right. Hell yeah. Hell yeah, bruh. Um, it's so funny that these notification suggestions they ask you more notifications than the actual thing. It's like so freaking annoying. Um, okay, so let's just hook up the second motor because so while we're at it. Um, or should we design the thing now? We need to design. Okay, so I'm gonna. Oh my gosh, dude! I'm so happy. This thing moves so fast. Okay, wait. We should set up pulse width. So we should try to set this at half speed. Okay. So I don't know how to do that. Um. Okay. The enable pin is supposed to be used with pulse width modulation to control the speed. I want to set forward to 10% speed on input 1. But how do I do that using my Pico W? Oh, okay. I see something in the data sheet that I got in the package from Amazon that says enable signal terminal input PWM adjustable speed, PWM frequency range 0 to 10 kilohertz. Um, what I don't understand is does the PCB have a way to determine the clock cycle or the frequency of the like how will the motor driver know that I set the PWM frequency to 1 kilohertz or whatever? Oh, okay. Okay, so let's try that. Um, let's make a folder. Okay. Bing, bing, log, 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 log. Okay. Okay, pretty straightforward. Sick. So yeah, I'm a master at DC motors now. Okay, I want to look at the current draw. Okay, so let's. Okay. So for 10% speed, oh, it really does not use that much current at all. This thing is using like, when it's on, like 0.2 amps. Let's see a 50. Oh, it never got the, right. It's only using a third of an amp. Wow, this thing is strong. You can feel it when it hits the brakes. It's like slams it. That's sweet. Okay. Well, I feel very accomplished that this actually worked. You know, it's funny because when you put all this new stuff together, you just like there's so many unknowns that you're just so worried about it like not working, but it works. I wonder if that's really like oh shit. I really wonder if that's actually 20,000 RPM. This is rad, man. That thing moves so fast. Okay, so now we got the motor working. We got pulse width, speed control working. What was on my to-do list anyways? So, okay. Yeah, we did that. Um, um, yeah, we did that. And we did this. So we've done most of the things that we sort of needed to do to get running. So now I can put away a lot of this stuff and we can just start designing. So it's going to be mostly a CAD day from here on out, I feel like. So, okay. Wow, that was extremely successful. I am so happy. Okay. So here's what I'm going to do. Oh yeah. It's great when stuff just works. Um.
Intuition, I don't want it, I won't take my own advice. Pothole, no handlebars, gaslight burning under stars. Ain't no pain, I'm gonna die in my wrist, in a lie, I won't sleep. All my money, I some shit I don't want. Ain't no sense in the dark, in my chest, in a night, I won't stay where it's sunny. If I can't leave the block, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it, I hate it. Can't believe I thought I would want this. Throw away everything I own. Running laps and it right where I started. Burning that wood bridge on the roof of my apartment. Who, if I got it, running on a feeling, thought I knew I forgot it. Neck against the ceiling, wear a suit if I got it. Tied up for a minute, couldn't prove I was drowning. I sent them a location, I sent, I paid for the vacation, I can't ever show face shit, I sent them a location,
Don't know when I'm falling, darling, when I'm falling. I'ma quit.
Ain't no pain, I'm gonna die in my wrist, in a lie, I won't sleep. All my money, I some shit I don't want. Ain't no sense in the dark, in my chest, in a night, I won't stay where it's sunny. If I can't leave the block,
Run it up.
run it up. Said enough, no, when it up. Fuck it up, I'm on the benches. Lace the forces up for luck. I feel the tension, dark and wishing. Wash the dirt up off my cuffs. Ride it up, give me some space. I'm sided up, can't feel in my face. I lined it up, pick up the pace. I tied it up, you in the race. My partner, in the way. I tried it up, my feelings are raised. I'm shining now, I'm feeling okay. I'll ride it out. Hold up on a mission, if I got it, I'ma run it till I die. I'ma make my life a show, just to show them I'm alive. Intuition, I don't want it, I won't take my own advice. Pothole, no handlebars, gaslight burning under stars. Ain't no pain, I'm gonna die in my wrist, in a lie, I won't sleep. All my money, I some shit I don't want. Ain't no sense in the dark, in my chest, in a night, I won't stay where it's sunny. If I can't leave the block, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it. Thanks so much, I hate it, I hate it, I hate it, I hate it.
Can't believe I thought I was.
Throw away everything I own.
Where's my notebook, bro? What the heck?
Running laps and it right.
Where's my notebook? Okay. All right. Oh yeah, and then the other right, and then wait, I actually have a keep note. Let me go private. Let me just put this. Okay. Right. So this is what I had written down on my backpacking trip. Is what I need to do. So yeah. So this is yeah. So this is a big one. I really want to do that. Oh yeah, I want to switch to pose detection. It would be fun to do model quantization, but uh, let's just keep pushing on the projectile. Okay. So let me just do an initial sketch of what I. Okay. All right. So let me just like show sort of what I imagine this. Um, oh wait, we probably need to. Okay. So let me just. Maybe I'll get. I gotta go get my calipers now. But basically, we need a model. Okay, so let's we need a model this, and we need a model this. The motor and the bracket. Okay, so fair enough. I'll get the calipers, and then actually, if I who made this? They are pretty quiet, actually, though. I will give them that. Oh, you need to give it 24 volts to get up to. Okay, okay. We'll need to do some actual math to figure out how big to make the flywheel. But let's see if they give me any dimensions. Dude, these dimensions are actual shit. Under load, it probably, yeah, right. That's what my dad was saying. Under load, it probably, I mean, because there's nothing holding on to this thing. Okay. Massage chair? When are you going to need this in a massage chair? Oh, yeah, with a gear reduction and to move it up and down? I get it. 10,000 RPM, that's like 160 times a second. So what is the angular velocity then? That is an angular velocity, but in seconds is I guess what I mean. Whatever. Okay, let me get the calipers and we'll start modeling. I think that's the best thing to do. Nice, I already had them. It's always nice when you have the tool. Who the hell put this in inches, bro? What the frick? What am I? An imperialist? What am I, a pig? Okay. So let's just do the plate first so that I can get this. $2.5. Okay, so let's just do so we're gonna do this. This is mounting bracket. Okay. Then up here, what did I do? I did control P. Was it control P? What? Alt P? What? I thought um I thought I did that. Maybe it was on my other computer that I did that. Bracket thickness. Okay. It's square, so that's nice. 52.4. Oh wait. Okay. Oh wait. Wait, no. It's 50. Yeah. Okay. The diameter of the motor. Wait, is it 50? Did I just mess that up like big time? I feel like 50 is the right number. Ugh, I'm so bad at using calipers because I feel like yeah, see, I'm getting 51. Yeah, the problem is if I get this wrong, then the holes will be off, which is not ideal. I hate this. I wish they just gave me the right dimensions. Okay, let's use the calipers and then just okay. Yeah, okay. Then we got to get the shaft geometry right. Okay, there's a lot to do. 17.4. Um, what do you call that? No, wait. Motor diam is stupid. Motor. I'm just gonna ask ChatGPT. My DC motor is a cylinder, but there is a smaller cylinder that extrudes a bit higher. What is that? What should I name the parameter for that diameter? Shoots a bit higher and surrounds the shaft. What should I name the parameter for that infusion? I just want to see what it says. Collar. I like that. Motor collar. And it's 17.4. And then I want to look at where are the dimensions? And then what is the height of that thing? Okay, so the overall height. Or length. Yeah, we're going to call it length. Motor length is 66.5. Okay. Yeah, and I'm getting that. Motor length 66.5. Okay, and then the extrusion there is like 5 up. Okay. Oh. Okay, now the shaft. $16.39. Okay. What did I say? I think it's just 16. Let's just make it 16. The question is the geometry. Well, it doesn't really matter, but of the D slot. Okay, wait. Let's just see. Okay, we're going to do a new component called motor. And then within that is a motor house. Right, but then within this is a shaft. Okay, that's fine. And we want them to be two different components because, yeah. So, okay, so let's activate motor house. Okay, cool. Yeah. Did we even get that? We did not get that. Mounting hole pitch. Oh, that's nice. Okay, so I think we have them all. Okay, so this is gonna be 40, or wait, uh, okay, then this gets extruded by, oh, and then we need this, I think the collar goes on the other side, right? So we actually need to, and then how much does this extrude out? 7? And what is the shaft diameter is 5, right? Most shaft diameters are 5. And it's usually pretty precise, which is also nice. Oh, oh, I knew it. Wait, did I know it? No. Motor shaft di. Okay. Wait, did I? What? Okay, and then extrude this by 7. Oh, wait, but this is actually. No, but you know what? That's not really what we want because that thing goes all the way through and we need to account for that. But for right now, I think it's fine. So then on here, we're going to do the exact same thing. And we just need to do a cut and we need to figure out, yeah, how much to cut. And then there's a small fillet, but that's fine. Okay. So, it's going to be, oh, I wish I could do this. I wish, this is why open source software would be so much better. If I could just make their thing actually good. Oh, uh, okay. Is that right? Is that everything? We just need to make this. Okay, that's almost 100. That probably is right. Thank God this thing is metric. I'm coming up with 98. Yeah, that sort of checks out actually. But whatever, it's close enough. Okay. Um Okay, so we have it, right? We just need to do this, motor, collar diam. What is that what it said? I don't think it had a Oh, wait, hold on. Okay, now in here we want the Here's what I'm going to do. I'm going to draw a shaft diam hole here. I'm going to extrude this all the way through, actually. So this is kind of whatever. But now I'm going to activate shaft. Why don't we design it from the bottom? So first we're going to construct an offset plane from here by shaft back, yeah. Okay, we're going to draw a circle on here that's 5 millimeters. And we're going to extrude this by, we can't actually use shaft total length, which is really annoying, because then it will be wrong. No, so instead what we'll do is we'll undo that and we'll make it, because this is the length that really matters, is shaft. Okay. Or extrude this by, and then let's do shaft total length. Okay. So now the height here is not 7, which is kind of annoying. Oh, it is 7. But then what's the height here? Oh, no, you know what? It is, right? It's just that this is like, okay, so we're good. Here. Okay, perfect. So now all we need to do is we need to cut the D. We gotta cut that D. .36. Let's do 3.5. And then let's see, what's the depth on that? $13.25. Okay, 13.25. Okay, so what we need to do. Why is my mouse being weird? Okay, so we're gonna do. First, there is a slight fillet, but let's maybe do that after. Okay, so we need to make a line that's vertical and coincident. So we have two coincident. You make the distance from here to here. Oh wait, what is that going to be? It's going to be 2.5. It's going to be. But if the distance between here to here. Yeah, wait, hold on. Do this. What did I say? 3.25? No, I said 3.5, right? Yeah. Yeah, so that means that this is 1. Okay, so I'd rather just do it like that. Okay, so now we want to extrude this minus 13.25. That looks pretty good. Now, the only thing is this is a fillet of maybe like 0.5. I don't know how you... That seems right. I don't know how you measure that. Okay, so now... And then there's probably a fillet on here. Okay, so now we just need to do a joint, as-built joint. So let's do this, Shift J. Perfect. I'm so bad. I'm so naughty. I'm making a new project again. This is going to be ball shooter. Okay. So we have the motor done. And this is like close enough. Is that really to scale? I feel like it's I feel like this is wrong. The height of this thing 66.5. Why does it just look so disproportionate though? That's what I don't get. Also, there's this casing on here. It's 42, but it's really 44 and a half. So I'm going to change that. That looks closer to what it is. Okay. Um, so this needs to be mounting. Hold on. Oh wait. Oh yeah, we forgot. Hold on. We need to add 2 holes that are probably, well, they're sort of as deep as you need. But I'm not going to go that far to model the inner casing of this thing because that's too much work. Okay. Let's see here. So we need to okay, let's motor house sketch. Oh yeah, can we get the Uh-oh, where did I put those? Oh, there. I'm almost positive they're M5s. You can just tell. You can just tell, my man. Okay, well, it says 3.6. Does it say? Oh, wait, I have my... I can just check. It says on the calipers that it's 3.7 or something, but my guess is that these are... Oh, maybe they're M4. Okay, well, they're definitely not M5, so they're probably M4. Yep. Okay, perfect. So we can just make the holes 4. Do I get a vertical? Hello? I don't get a center? That's super annoying. Okay. Okay. Now we just need to extrude it by 10. Should we thread them? It's definitely not that. It's probably this. Oh wait, we didn't need to do model. Oh. Okay. All right, now we can go back to the bracket. It's gonna be bracket height. Wait, am I a dumbass? Yeah, I am. So we want this plus. Oh. Okay. What? I said X. Oh. Okay, so we're doing. I didn't actually check. Because this actually does not look. Oh, yeah. I'm dumb as hell. Okay, so this is the width. $52.5. Okay, so one of them is 50. And then. Okay, so that's the height. Bracket thickness. Bracket height. Bracket height is 50. No, wait. Bracket height is oh, you can't undo that. That's an L. Something like that. $51.25 minus. Okay. Dude, why am I being so dumb? No, because that is the extrusion amount. Bracket height is the extrusion amount. Okay. So wait, so this. Okay, and then this is 50. So we're kind of doing this. Actually, I want to make this. I want to swap these. This is going to be bracket width. Oh. Okay. No, I want to do. Oh my god, I'm so stupid. Bracket width 50. Okay, okay. So it's going to be facing this way. Okay, all right. So now we need to draw these slots. So first off, I'm making construction line. Okay, so then, oh, but yeah, so we need a line that's, wait, is it going to be 1.25 or 2.5? It's going to be 1.25. Oh, wait, okay, and then now we're going to do, it's like 2 lines, and then these are equal. These are horizontal. Then we need a arc. Is it tangent arc? Yeah. And I believe if I set this, I'm good. No. Oh, positioning. Yeah, positioning. Let's think about that. Oh, so that's 10. Okay. So wait, how do I make the distance between here and here? 10. How do I even get that? Okay, wait, what's the radius? Oh, interesting. Oh, interesting. Okay. So this needs to be, so wait, so what is the actual, so wait, what's the thickness of it? That's what I want to know. 4. 4.25. That determines the radius, right? So this will be driven? Yeah. Okay. So this is going to be 10 minus 2 times, and it's fully constrained, except for, so why is it vertically constrained? What is constraining this thing vertically? What? That's so weird. Okay, so the distance from here to here is 25, right? So the distance to this center point, the distance to that center point needs to be 25. So we want to do, wait, yeah, 25 over 2, or wait, yeah. 25 over 2 minus 5, minus this over 2. Is that centered? That doesn't look that centered. And then here to here is going to be... So, wait, so what is the width of this thing? It's 50. 50, so then this should be 12.5. But that's definitely wrong. But the distance between here and here should be 25. Oh, right. Minus... Okay. I think we're good now. Sweet. And this is also a construction line. Oh, wait. Okay. It's probably a little bit more than that. It's actually, the tolerance was pretty tight when I checked. 17.44. So yeah, keep that as is. This is not construction though. And then these are M4s, so we can make them like 4.2. And then the distance is going to be, oh, damn it. Okay. Okay, so the mounting bracket is done. Let's turn this back on. And then we want to mount, so let's do this J here. Oh, oh wait, that's, no. Yeah, something looks off there. Why was that, why is that wrong? Oh, wait, hold on. Cool. All right. Very good. Why is there so little clearance? I feel like there was more clearance. There's definitely more clearance in the actual part. It must be not centered. Oh, you know what it is? It's centered on this face. So we need to actually go here. When we draw this, we need to remove this. Yeah. So wait, can we move this up now? Woo, woo, woo. Okay. So what we want to do is this to here is is it bracket thickness over 2? Let me think about it. What is the center point on this face? Wait, let's finish sketch. Hide this. I just want to draw a face on here and just look. What did we say this was? 48.75, but what is, that's this. Okay, so 24. Okay, so wait, let's just finish that. So let's copy that number. 24 point. You can't copy it? What the hell? That's crazy. Okay, whatever. Let me just write it down. Okay, so who cares? So this here to here needs to be it needs to be 24.375 plus 2.5. What is that? $26.875. Okay, cool. So I did all the math right. So now we just need to say that there's a point here. Oh. Okay, and then here and here is vertical. Okay, and then actually we delete this. The distance between here and here is mounting pitch over 2. Okay. So now I think we're good. Oh, but no, but these need to be actually no. So I'm done as hell. That horizontal constraint is bogus. This and this are probably horizontal. Oops. Oh wait, there's some coincident thing. Is this coincidence? What is that? No, that's a mirror. Oh, there's the coincident. Okay, so now okay. That seems right. So now, does the joint still work? Okay, that looks right. Cool. And it is a very snug fit. Okay, so I think I don't even really want to use this bracket. Let's see, how long have I been going? 3:20. Still got 5 hours left, bruzza. Um, so yeah, so what I'm saying is we need to do some math because there's a lot of physics that I don't understand. Okay, so my plan is to have two motors with flywheels um, that spin in opposite directions. A Nerf rival round is pushed into the flywheels. Help me work through the physics. So my plan is to have two motors spin in opposite directions. A Nerf rival round is pushed into the flywheels. First, what determines whether the Nerf gets pushed back versus through the flywheels and propelled forward? That's a huge unknown. Presumably, it's going at 10,000 RPM, but like, I don't really have a way to determine that. The speed at which each flywheel is spinning directly affects how much momentum is transferred to the Nerf round. Grip contact between flywheels and round. The friction between the surface of the flywheels the force with which the Nerf round is pushed into the flywheels affects how the round interacts with them. If the pusher force is too low, the round might not make sufficient contact with the flywheels and could be bounced back. I mean, this is literally a pitching robot. Literally. 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 Bah. Yeah, most of the paint would be wasted just because. Yeah. Most of the paint will be wasted. For sure. It's a good and bad thing. Yeah, that's just gonna. You're just gonna have to cross that bridge when you get to it. Okay. Right. Yeah. The velocity of the outer diameter of the flywheel is just the angular velocity times the radius. Okay, let's work through this. The force transferred from the flywheels to the nerf round is related to the torque and speed of the motors. You can calculate the tangential velocity. Yeah, that's what it's called, tangential velocity. At the point where they contact the nerf round. N is the normal force, which depends on how tightly the round is pressed against the flywheels, influenced by the flywheel's compression on the round and the pusher force. Right. Right. Ensure that the flywheels have enough angular velocity and momentum to overcome the inertia of the round. I don't know really. The pusher mechanism. That is something that I really did not consider. I sort of imagine just poking it with a stick to start. Okay, that's great. So, okay, so what's up with this URL? It's weird as hell. Wait, actually, I didn't ever take a picture of that torque speed curve. Let me take a picture of this so I don't lose it. Is this the dimensions? Oh, yeah, this is a. Motor performance curves. This graph is ridiculous. I wonder what was limiting my current, because this is a no load. It got 10,000 RPM with 1.1 amps, but I only got a third of an amp, and who knows, presumably it was only going at 3,000 RPM, which is 50 times a second. Um, what the hell? Um, um, well, what is the trade-off for clearly a bigger flywheel will have a higher velocity, but what is the drawback? I think we should just guess a number. I don't think it's going to be all that big of a deal. I mean, clearly it is eventually, but not right now. So, okay, so what are we doing? We're ignoring the bracket. So, um, maybe I should just start over and just do an insert derive. Okay, so let me just think about this. Okay, oh yeah. Well, we lose all our parameters though. Yeah, maybe I'll just delete the joint and disable the thing. Okay, so um what was it? 7 ace. Okay, cool. I mean, you can compress this to like half. You can compress this like half if you really try. So, what is the physics of like what is the relationship of the compression of the nerf and the friction force? The friction force is the coefficient of friction. Right. So the nerf is a spring effectively and most likely doesn't have a linear curve defining the normal force for a given amount of compression. Probably. Nerf round being made of foam behaves like a nonlinear spring. I don't know how you. Yeah, it is probably some sort of exponential though, or how could I measure this? Yeah, modeling the foam. Yeah, I need a stress strain curve. Do I probably have a force sensor? I mean, I feel like it's a side quest, but I definitely want to model the nonlinear spring. The what is it called? The model the compression of the nerf rival round. Model experimentally determine. Yeah, because it would be cool to get the physics actually down. Like this is supposed to be a real project, not just like a bullshit let's guess type of thing. I think for right now, let's just do 5 millimeters because tonight I really want to get something shooting. I don't want to just like have nothing. It's already 2 p.m. So, okay, so we're gonna rigid. Oh yeah, let's just delete this. Oh wait, can we No. Yeah, let's just delete this and disable this. Okay, cool. Okay, before we do that, let's get half of it down. Okay. So, wait, but we need to determine the flywheel. We need to determine the flywheel diameter. Okay, so wait. How do I read how do I read this graph? There's no legend. This graph is total bullshit. Oh wait, there is a legend. Let me just Google motor performance curve.
Hello guys, welcome to another video of the course. In this video, we will discuss the calculation of the performance curves of the motor using the MATLAB software and the Simulink model that we prepared in the previous video. So here you can see the performance curves of the WEG motor. As you can see, the efficiency drops by reducing the value of the output torque. Right here, as you can see, we have these three important working points. When the output power is half, efficiency is 67, and here efficiency is 72 when we have the 75% of the output torque, and also we have reduction of the power factor when we reduce the output power. So you can see these curves and this data also here. This is the efficiency curve. The green one is the power factor. As you can see here, we have the maximum power factor for the maximum load.
Oh. The maximum efficiency, the efficiency is 71.8%. The torque is 70 Newton meters minus meters. I don't really get what that is. The speed was about 9,000 RPM. The current was 7 amps, about. And the output was 60 watts. Okay, let's see. This maximum at 8,900. The current was 7 amps. I can't tell. It doesn't. I don't know. Power typically follows a parabolic shape because power equals torque times angular velocity. At zero torque, wait, what is torque? Right, it's a rotational force. Okay. But we don't care about the efficiency really, right? What we care about is, so let's just set a a speed of, let's just say we want to shoot the ball at 50 meters per second. Okay. Let me work backward. If the Nerf rival round is 7/8 inch, And I want to shoot it 50 meters a second. Help me define the size of the flywheel and then check if my motor can handle it. Because I want to know, can I shoot at 50 millimeters a second? The speed at which the Nerf round is propelled depends on the tangential velocity of the flywheels. Yep. Let's assume the flywheel diameter is roughly 2 times the diameter of the Nerf. Okay. That's pretty small. I was sort of assuming it'd be big, but yeah. Okay. 2,000 radians a second. That's only like 1,000 RPM. Oh no, that's. Yeah, I can't do that. That's really. Hmm. So we can increase the size of the flywheel. Oh, the diameter is 50 millimeters. That's pretty big, though. Yeah, maybe that was kind of what I was imagining. Now that we know the required flywheel RPM, we need to check if your motor can achieve this speed while providing enough torque to drive the flywheels with the necessary force. The torque required depends on the mass and radius of the flywheel and the angular acceleration needed to maintain the desired RPM while launching. Yeah, it needs to be going 20,000 under load while it's compressed. That's pretty crazy. Let's estimate the torque required to spin the flywheel. The moment of inertia for a solid disc like a flywheel. Okay. I would need to double check if that even makes sense. Next, we need to estimate the angular acceleration required to spin the flywheel up to speed. Why does that matter? But I think that that's at its maximum. Oh. Hmm. Yeah, I'm dumb as hell. Yeah. Duh. Wait, millinewton meters? Dude, what is up with this bullshit? See, that's what I'm saying. That's not even at maximum power output where it's going 5,000 RPM. Yeah, I don't think this motor can actually do that. Okay, so if that's the case, I'm gonna make the flywheel design right now. Executive decision. What's going on, Isabel Joseph? What's going on? Okay. That was 10 minutes ago. Anyways, yeah. So let's just make it 75. 75, is that too big? Yeah, that's 3 times the size of the Nerf rival round. Let's try it. The Nerf compression should be. Let's do 5. Okay. How do I want this to Yeah, we always just design the stupidest thing you can imagine. So this needs to be, let's see. It needs to be at least 2 times. Oh, wait. The flywheel can come out at the over the end, but let's say 10 of clearance from the edge. So 10, then the motor, which is 44. Then this thing outside of it is 75. Then we need this to be 22.225 or whatever minus 5, right? That defines the compression. Then another one. Then this is mirrored. So that's, hold on. So this is going to be 10 plus 2 times motor diameter. But that's actually not, hold on. Oh yeah, okay, so then the 75 over 2 is 37.5 minus 22.5. Yeah, it's just 15. So we need 15 extra. Hmm. And this is all, wait, plus 2.5. This is all times 2. Okay, so this is 10 plus 44.5 plus 15. Because what we care about is this to here. This is, okay, so it's actually, yeah, it's the same thing. It's going to be 10 plus 44.5 over 2 plus 37.5 over 2 plus 2.5 times 2. Okay. Let's write it again. 2 times 10 plus motor diameter over 2 plus flywheel diameter over 2 plus 2.5 plus 2.5. And the height of it can just be the height of it can just be 50. Who cares? Why does it even matter? Okay, yeah, let's make it 50. So let's just get it down. Okay. So now we just need our mounting circles, the collar circle. Okay. So let's draw construction lines. So wait, this is going to be okay. So this, the distance between here and here is going to be 10 plus motor diameter over 2. Okay, then we want to draw a circle from here that's flywheel diam. And that's a construction line. So then we want to mirror both of these. Oh wait, but let's do the mirror after. So then we want we could put the mounting this way. Which is better? I don't know. I don't think it really matters. This is gonna be 4.2. This needs to be right. That should be how it is. Okay, so now we can just take this, 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 and this, and mirror it across here. Okay, now I want to know the distance between here. It's 5? That's not right. I did my math wrong. Oh, it needs to be plus. It needs to be plus 22.225 minus 5 over 2. Okay. Okay. So, yeah. Let's just make that fix. Okay. It's 209. Okay. So this needs to be nerf diam minus nerf compression over 2. Okay. Now if we do this. Yeah. Okay, cool. Now what is that? It's 156. Yes, we can print that. So now we basically just want to extrude this by 5. And we'll need a longer M4, but that's perfectly fine too. Wait, can I go back to the sketch? Let's see, what determines the distance? This is it's not the midpoint. Oh, wait, yeah, okay. This is 10 plus the motor diameter over 2. So if we make the walls 5 mils,这生我可以好的好的。Okay. Can I get some of that freaking Chinese balladry going on, dude? We really only need this. Okay, and then this needs to be motor length plus ten. I don't know. Let me do a.这是一个 75. So we need. What is that? I wish it showed me both. What is that? Why doesn't it tell me? What the hell? Yes, but what is it? 81. Okay. Oh, if I just click on this, but it still maintains the. If I press enter now. Okay, it still maintains. Oh, this just. Okay, so yeah. Cool. That should be good. But we need to make this a little bit stronger, I'm guessing. Okay, so now what I want to do is I want to turn this on. I want to do a copy. Wait, so copy, paste. Okay. Wait, so now we want to fix this because this is grounded. It's this goes to here. Okay. Okay, sweet. So now we just need to design the flywheel. Can I move this to you can't move it? It's so stupid, man. What the hell? Whatever. I don't care. Um That's a hunk of freaking plastic. Jesus. And we want to groove it. We actually want to groove it at some point. So wait, so let's change this to be. It just doesn't need to be. For a first test, we really don't need it to be Okay, so now we need to figure out what's going on here because ooh, what are the 3D printing add-ins? That's cool as hell. Okay. They're not unviewable, but dude, I really want this to work. This would be so sick. Ugh, fucking. Wait, what? Oh, I don't have my. Yeah, hold on. Nah. Uh, Okay, wait, hold on. It's probably this process. Fine. If you insist on being a total turd. Wait, what is that folder called? Oh, but it's called Fusion Scripts. I'm dumb as hell. Okay. Sweet. Okay, it should be fine. I mean, the paths are all right, so let's see. Cool. So let's make a new thing, called it solo. Python. Let's just save my choice. Create. Okay. We can close this. That's so annoying. Okay. Let's try it. Okay. It's saved. Let's run it. Did I make a note? Did I make a readme in the thing that says how to do it? Okay. Yeah, so occurrence is visible. Yeah, so it just made that up. Property of occurrence objects has no setter. But the problem is you don't get, dude, developing these things is so brutal. All right, I give up, but I do really want to make that work. Whatever. So what am I doing now? I'm designing the flywheel. I wonder if I should make it smooth. Like maybe just adding teeth to it. Well, let's just try this. Okay, so what happens? What happens? So this thing is 5 thick, right? So it should be flush. So wait, let's see if it is. Right, so this is flush up against there. Which means we have 17 millimeters. So yeah, so we can't really make this thing all that. Oh no, we can. Okay, so why don't we do this? We maybe it goes like 17.4 whatever. Then it goes out even more by 17. Or what, 17? This is 5 millimeters, so we want an M5 in here. Okay, so we I'm gonna circle here. That's how did we decide? We decided for the gears that it was based on the root diameter of the gear. So, but here we're not really bound by that. We basically, the minimum we need to make it is, let's say 5 plus 5 for clearance. Wait, no. Hold on. Based on the radius, 2.5, then another 2.5. Then for the M5 nut, 3.75 or whatever. Or let's just say 4. And then let's say 5 more. 5 more. Let's do 7.5 then. I mean, it really doesn't have to be that much at all. But so, okay, so it's going to be 5 plus 4 plus 7.5. Okay. And so this is going to be extruded by, oh, wait, but we forgot something in our sketch, which is a circle that is 5.2. We want it to be snug. 5.3. So we're going to extrude this by 17. And what actually is that distance? 16.5. That's perfect because that's within the... I mean, we don't want it to contact it at all, but whatever. That should be fine. Oh, well, then we could just extrude this by... So this is shaft height. Shaft length minus 1. Okay. Okay, but that is maybe where we have an issue. No, I mean, that looks long. So now we just need to draw the sketch on here. Wait. Oh, you know what? I did this wrong. This is a radius calculation. Okay, that checks out way more. Wow, that's a thick boy. Let's change that 7.5 to be 5. Okay. Why are there 2 extrusions here? I don't understand that. What is this one? What is this one? Wait, I did 17. Delete this. Delete this. Okay. Okay. So this is going to be 4. And this is going to be the flats distance, which somehow I still have not memorized. Can we just open up an existing design? Pretty sure these take M5s. We will find out. Yeah, see, I just want to solo it. It's so insane. So this is 5.2. So it's hide this. .2. I'm down to do 8.2. I remember it being loose the other way. Okay. So we're going to extrude this down. Oh, the better way to do it is just activate it. I'm so stupid. All the time, I'm so stupid. And I just want to look. Okay, this is all that. And this is that. I think it's this one. And I made it 7. So the question is, if I make it go down 7, because we want it to be as much as possible, actually. So can we, so it's 9. So let's make it 10. Wait, but then the head, right, the question is the head. The head's only 7. Right, I see. Okay, so let's make it 10. Oh. Okay. And what is the height of this thing? It's 16? Oh, so if we go down 10, then the center of this circle, so this is 10 millimeters. So that's where the center of the circle is going to be. So let's say we have this, and then we have this. This is 10, and this is 6. So if we have a circle drawn with a diameter of 7, we'll have 3 millimeters of, or, we'll have clearance. So that's fine. Oops. Wait, let's, okay. Wait, 5.2? Oh, if that's the case, we need to. I was doing everything off of M5, but yeah, that's right. These are M4s, but no, but I actually wanna. Yeah, okay. Um. So what am I doing? Yeah, I'm measuring this. I mean, I'm pretty sure I'm still gonna have clearance, but because that's 8.4. So yeah, so I still have like basically a millimeter and a half of clearance. Okay. Now I'm gonna draw again on here. Cool. And actually, I want to go back. I'm gonna make it 4.1, I think. Nah, fuck it. Nah, we'll do 4.1. Is that enough? So, okay, it's going to be, that's 2.4. I think that's going to be enough. So now we just need to mirror these features. Okay, cool. The question is whether or not this bolt is going to hit there instead of there. So what do we have from that face to this face? 2.75. So I think we need to change that extrusion to be 9 or something. because now the distance between here and here is 3.4, which is greater than the distance between this face and this face. Which is, if you put it on top of it, the bolt goes through, it's going to hit the shaft. All right, so we're good. We can now copy this and add the joints. So first off, join, yeah, this to there. Yeah, that seems right. Now we need to copy, paste. Let's just move it out here. Okay, now I should be able to turn these, right? Oh, wait, no, but I didn't connect it to the shaft. Let's undo this, undo this. Wait, we can't move it down 16, right? Wait, let me click OK. Do this. Then what is this? This initial extrusion is 15. So we need to, you're right. So we need to go back here, edit the joint. This is not 16, but 15. Oh, so we actually have more room to play with because I forgot about that. We have 1 extra millimeter. So we kind of... Oh, plus it's the other way around, dude. I'm so bad at flipping it in my mind. So it actually doesn't matter. But this should be fine. So now we can copy this and paste it, and then move this out here and join it. Wait, let's make sure that this. Did I get this right? Okay, cool. This and this 15. Cool. So is this all we need, man? What? 25. Wait, why is that so? Oh no, yeah, that's right. But actually, is this stupid as hell? Because now there's a big lever going this way. I don't know if I like the fact that there's so much space here. The bolt will hold it in. I think we should just print this. See how long have we been going? 440. All right, this will probably take a while to print too, so and then we got to write the software to. Okay, so let's say a prototype. Okay. I think that's the only two parts is the holder and then the. Maybe I could split the difference and make the wall thickness 3 mils. Wait, what? This is stupid. This is no way to. Okay. $2. In the meantime, I guess I could try to fix. Mm. I think I don't want to risk. Well, I only have 1 pico left. I don't want to risk breaking it on this stupid thing, but maybe that's just like me being really dumb. I'm gonna try plugging it in again. I feel like I'm pretty sure it's busted, but I just don't know why it's busted. Okay, well, let's print this out. So these are M4s. Okay. See, that's the thing about solo is you can't actually click on this stupid thing. Wait, I'm gonna cancel this. I don't think that there's enough clearance there. So if we activate this, let's go away, bro. 17.8. No, that's enough. Wait, 0.2 around? Yeah, that's good. I'm down with that. Oh, but we need something to. We need a way to hold this to the ground. We need to fasten this to something heavy, man. Um. Ay. Should I cancel it and try to redesign? I'm trying to think what I would do. Um. Put a piece of wood on it. Put it. I mean, like. Right. When you're doing this, you got to think ahead. Like, what could I make this so that I could actually use it for longer? Because prototypes. That's the thing about prototypes is that you need. If you spend a bunch of time on the prototype, you gotta. So maybe I should just go ahead, and then I can put it on a piece of wood or something. Screw it in. Well, I could just design a bracket that goes onto it. I could just use these brackets too. Okay, so I'm gonna keep it going because whatever. So what else is on the to-do list? So we sort of designed a prototype for a flywheel and stuff. Okay. Okay, well, we can at least do the wiring. Um, the wiring and I guess the programming. Okay. Jesus. Okay. Um. So let's move all this crap. Okay. Um. Okay, so we just need to take okay. Okay, we need 5 more of these. And this is going to be annoying, actually, because I don't know if I have 5 more of these. Okay, 1. 2. Sure. 3. Yellow. 4. And black. Five. Okay. 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 Let's do this thing. One. Wait, let's make sure the cable management thing is done. Okay. Ground. The 5 volts. Next is the PWM. Okay. Um, GP4. Wait, this on pin 6. So we have GP5. Okay. GP6, which is what the hell? Okay, that makes things easier. GP5 then ground, and GP6 is on 9. Then, lastly, that one fell out like so easy. This one's busted. There we go. Oh, these colors actually worked out really well. Wait, where's my blue? That blue is so loose. Oh, whatever. So blue. Blue is pin 9. And yellow is pin 10. Cool. Now I need to maybe about that much. Okay. Yeah, I'll do that. Okay. And then this one can be longer. Crimp will actually work better without the solder. Okay. Okay, those aren't going anywhere. Let's get our crimp. We need 2 of these. It's nice that they gave me these. Otherwise, I would have soldered to them, and it's like, then you got to desolder them when you want to finalize it, and it's like, oh my god. Okay. White goes to red. Okay. Slap that on there. Oh wait, actually no, this is what you're supposed to do. Ugh, there's freaking flies everywhere. Okay. Slide that on. Slide that in. Damn it. Maybe I do need a solder. Fuck it. It's good enough. No, it is not. No, it's not good enough. Okay. So I'm going to go solder the leads on these. But I kind of fucked up this yeah, it's actually fine. I think it'll be okay. Okay, give me a minute. Okay, so the problem is, yeah, you need to cover these in solder, otherwise it's not going to work. Okay. See if this works. Okay. Okay, we need to split this open again. What can I put in there? It needs to be really thin. Maybe a. Maybe just my pen. Okay, that might be good enough. So let's get this thing over there. Okay. Come on, bro. These connectors suck. I hate these connectors. Okay. Nope. Come on, bro. This shit is so mid. Crimp it, bro. Crimp it. Okay, well. Jesus Christ. The problem is the wire is like kind of too thick for this crimp. Okay, there we go. That's pretty good. That's as good as we're gonna get. I'll get some electrical tape and just tie it off. Oh, come on, I don't have electrical tape. What? What the hell, bro? Okay, whatever. Let's do the next one. Maybe I'll crimp it first, actually. I'm going to try that. Because then I can sort of do it with precision. There we go. That's crimped. Or that's actually just destroyed. I just broke it. Whatever. That's in there. So now we just need this thing. Shove it in the wrong way. I don't give a fuck. I do not give a fuck at the moment. As long as it's shielded. Okay, I just got to get some electrical tape and we're good. Okay. Cool. Just for kicks, I'll put the bracket on too. Where's the bracket? Okay. I'm getting hungry. I might make lunch. Okay. Like that. Pops on. There you go. Okay. Okay. Okay, so let's see what's good. Is basically, this is motor 2. So we want this one to rotate counterclockwise, and we want this one to rotate clockwise. Okay. So let's go to the code. Okay. Let's see. We want to move these guys over and around. Move this guy out over here. Okay. Okay. This will probably get it. That's pretty good. Let's do that. Okay. I think that's right. Let's just make sure the pins are right. Okay. So N2 is on pin 7. That's GP5. And 6 and 7. Yeah, I think that's right. So let's run this thing. We just need to turn on the power supply, and then we need to connect the USB cable. Okay. So 5% speed, we should be good. So we're going to turn on the power supply. We're going to turn it to current. We are going to run the code. Okay, so something weird happened. Don't know what happened. Maybe 5% is too low. Oh, wait. This is probably what happened. Lol. Do 10%. Oh, wait. There we go. Okay. Oh. Wait, what happened? Okay, come on. Hello? There we go. I guess it can't move that. Okay. So this is moving the wrong way. So we want this one to be... Nice. Let me try to hold on to it. Oh, I can stall it. I can stall it really easily, actually. Damn. We try to gear it up or something. This one, why are they stalling? That's so weird. Let's do 10. I feel like it won't fail at 10. Let's see the current draw. Still not that much. Okay, let's do this thing. Oh yeah, half an amp. All right. All right, my friends. No, you can't even see them. Rest assured by the sound, they are absolutely going. They are going, they're going. Let's see how my print is doing. Oh, come on, bruh. This thing needs to print faster. I really want to launch something tonight. Yeah, that's pretty sweet. My guess is that they'll stall. That we'll need to find a speed that. Oh shit. I messed up the design again. I didn't think about the. Dude, I never think about the fasteners. This is why the cardinal sin is always put in your fasteners. Look at. Look at that. Oh, you gotta be kidding me, bro. I think what I'm gonna do is I'm just gonna counterbore. Let's see. Let's see what the thickness of these. Let's see. Hopefully, I can get that clearance so that I can get it in there. Because otherwise, we are screwed, my friend. We're screwed. So, um, that stinks, man. I always forget the fasteners. All right, so it's 4 thick, and the distance from here to here is 1 millimeter. So that means that I need a 3 millimeters deep, at least 3.5. But it cannot go all the way through, otherwise I can't mount it. So that's going to be a careful thing. Yeah, this board is dead, man. Oh, wait. What was that? I think that's the sound of it trying to make a connection and failing. Something weird. Okay. So he's pretty funny. Bro, I just want this print to finish. I'm too scared, dude. I'm too scared to blow up this Pico, man. The wiring is correct. That's the crazy part. What is this green wire? I think I need to send it, dude. I think I need to. It just sets me back so much if it breaks. I think I have more female to male jumpers. If that's the case, I could probably use. Okay. All right. Let's see. MicroPython with MicroPython and ESP32.
In this video, we will learn how to get started with MicroPython. I will walk you through in setting up your MicroPython environment, MicroPython 32 that will wipe to on. Download Tony Python, the map. You see, Micro is, by the way, these are the boards compatible with MicroPython. This is board, STM32, and this one, Wi-Fi with Y, and Express 8 boards, which are ESP8266, ESP32, and TinyPico. TinyPico is also ESP32, by the way. So download the generic ESP32 module, and scroll down, look for ESP32. Yeah, download the latest stable version. So for the stable, these are the stable versions. Or this one, 1.13. It's newly released last September 2. So I will download this one and save it to the folder of your choice. And I will choose again the folder I created in the desktop with MicroPython.
Okay, maybe that's something I do. I'll go get my ESP and we'll just try to get
Number 3, download the ESP32 USB driver from Silicon Labs website.
Oh, dude, I'm so glad he put that in.
Labs, yeah, this one and this one. It's under the scilabs.com.
Because I spent like hours not realizing that you have to do this.
The folder of your choice. I will save it again in the desktop, MicroPython folder. Start download. Okay. Number 4. And for later references, download the pin assignments or pin outs or a schematic diagram of your development board. You will be needing it later on to know, let's say, the pin assignment of the onboard LED. So I have here a copy of the pin assignments for this ESP32 development board. So I will post the link of this for you to download. I also have the schematic diagram, but this one is not exactly for this development board. Because
That's
this one has 36 pins.
That's the annoying thing about buying electronics off of Amazon is that there's so much junk, and I don't know why, and they just don't give you documentation.
Why this one has a total of 30 pins only? This is Do It ESP32 Dev Kit version 1 with 30 pins. Number 5. Now that we have all the necessary files, let's install the TonyPython IDE. So let's install the TonyPython. The reference IDE customizer. Some people can use 6 core x64 because I am using just click yes. Driver reads TonyPython is a call prompt of the MicroPython. But for the sake of tutorial, I will show you how to flash the ESP32. So that's why I'm TonyPython. I already have the MicroPython inside. So that's why I'm having this call prompt of the MicroPython. But for the sake of tutorial, I will show you how to flash the ESP32 with new firmware. To do that, click the tools menu in the TonyPython, manage plugins, and in the search box, type ESP tool and hit enter. Click install and give it some time downloading then installing. Okay, done. When you see the uninstall button here, I will just click close. Now we are ready to flash a new firmware to our ESP32. To do that, click again the tools menu, then select options and click the interpreter tabs. Then here, which interpreter or device should Tony use for running your code? I will select ESP32. It could be CircuitPython from Adafruit or MicroPython by using the BBC Microbit or MicroPython ESP32, 8266 or MicroPython generic. This one is using PyBoard. So let's select the MicroPython ESP32. Then in the ports, select the correct COM port, which is COM4. Then click open the dialog for installing or upgrading MicroPython on your device. I will click this one. And in the port, select again the COM4. And in the firmware, select browse and go to the folder you choose before. I choose the MicroPython folder in the
Oh, okay. All right.
bin file, which is the firmware with MicroPython.
Fair enough. All right, let's try to do that. Okay. What's it called? This is it. I mean, this is the chip, but this is not the PCB, right? Is it? See, on mine, pin 1 is not ground. That's the crazy thing, is that this total nonsense board, who is making this crap? Whatever. There's a pinout on the board, so I don't really care. I guess. This is the chip, right? This is not the maybe this is the PCB. No, this looks like the board. Dude, high let go is such shit. Ugh, come on, bro. Okay, whatever. Why do I even care? Okay. Thorny. Oh, sick. Wait. So what is the LED? Wait, I want to try to. Okay, wait. Let's see. Let's see if I can I held boot and it didn't make it a bootable drive. Okay, let's just try this. Pretty sure it's this. I don't know why. I mean, that's the great thing about Raspberry Pi and Picos. It's like they just they sell the board. There's not all this freaking nonsense. Okay. Let's just put it in source. Um, okay. Dude, what keeps going on? Yeah, see, bro. This keeps something switched my default Python to like 3.12. I do not want that. Oh, but I don't want to switch my Python. Let's just do it from within. Okay. Okay. No, bro. What the fuck? What's it? How do I rename this fucking thing? Oh, yeah. Dude, that is fucking insane, man. Where did this one even come from? Can I just delete this? Actually insane. Wait. Should I do that? I feel like that's a bad idea. How do I set Python to be this? Okay, so um what is it? I can't believe I have to do this crap. Yeah, I don't know where this came from. I'm uninstalling this shit. I don't care. Whoever did that is an idiot. Ah, everything is awful when you're on Windows because everything takes a million commands. Dude, no way only 20 minutes of 30 minutes have passed. Oh my god. Some days it's just like this, man. I could have just removed it from the path, probably. Okay, so now, if I do this, hello, hip. Okay, sick. All right, cool. So let's get back to business. Place com. Okay. Ba 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 ba, motherfucker. Wait, maybe it's just called ESP tool. What? Why doesn't Control W work? Okay, sick. What? Dude, for some reason the boot mode thing just didn't work for me. I'm holding down boot. The hell's going on here? Some weird grounding thing happened, I guess. Is it open because of this? No way, right? Dude, am I the stupidest son of a bitch alive? It's not in boot mode. Okay, wait, let's dude, this is why Picos are so much better. It's because you don't have to do all this crap. What are all these tools? I'm down to try that. I don't think that's it though. Do I have the right driver? I'm pretty sure I do. Dude, ESPs have given me so much more of a headache than Raspberry Pi stuff. It's giving Windows Apple. No, that's the right thing. I remember I was able to get this working. Should I just try another one? Okay, I'm gonna get another one. This one sucks. I'm so glad I bought more Picos. Because this is a nightmare. Dude, they don't show up as a bootable thing. Alright, wait, let's see. Let's just try it one more time. Dude, what the frick? Holy shit, this isn't even... Oh. Oh, wait, hold on. Okay, wait. No, yeah, they just don't show up as bootable things. Alright. Okay, well, I give up on ESPs. I think they suck and they're not fun to use. Dude, this print is taking way too long. I mean, we're basically just waiting on this thing. It's a huge bummer. I don't know why the ESP doesn't go into boot mode. How do I put my ESP32 in boot mode? For my Raspberry Pi Pico, all I do is hold down the boot button and then it like opens up in Windows Explorer as like a flash drive basically. But when I do that with my ESP, it just doesn't do it. No, what I'm saying is I'm trying to hook it up to my laptop. Hook up my ESP32 to my laptop. When I do that with my Pico, then and I hold down the boot button, then Windows will open up Windows Explorer and show the Raspberry Pi as a drive that is flashable. But when I do the equivalent thing by holding down boot on my ESP32 and plugging the USB into my computer, it doesn't show up as a bootable drive. And when I try to use ESP tool to flash it, it says that the COM port is busy, even though I verified that the COM port is right. And anyways. Oh, really? I forgot the end thing. All right, okay. I'm just being stupid, man. I'm not reading the directions. Let me watch that video, dude. What does he do?
converter installed. So I will open. Then make sure that the erase flash before installing is ticked or checked. Should be checked. Then click install. Give it some time until this one is successful. Okay, erasing is complete. Now writing. Now it's flashing a new firmware to the ESP32. Click OK, click close, and click OK. Now, the MicroPython is successfully installed to the ESP32 development board. Now, we can check this one. We can test some code. Let's make the onboard LED lights on and lights off. Making some code, import machine, and let's create a variable LED and set it to the pin 2, the onboard LED, and let's set the pin direction to output. And to turn on the LED, we just need to send LED.on.
Okay, so I'm gonna go up with the ESP again. It's just funny how little things in the design and user experience, like, gosh, it's so painful that I have to press 2 things. Why can't I just press 1 thing? Okay, fine. Let's try it one more time because I'm an idiot. All right, hold down boot. Okay. While holding the boot down, press and release the N button. Okay. Keep holding the boot button until you start the flashing process. Is that for real? Dude, no. What are you guys talking about? It's literally... All right, let me close everything. How about that? It's possible that the VS Code is like stealing it or something stupid. Let's close Thawny as well. Is Thawny open? Oh, wow. Okay. All right. Sick. So now, did I download that firmware? I think I did. Okay, so now, okay. Okay. La la la. I'm a freaking idiot. I don't think I need to be an admin. Okay, so now I should be able to just run code on it, right? So now, once this is done, I'm going to go to Thawny, and I should just be... Okay, what else does it say to do? How much time is left on this print? 16 minutes. All right, let's try to do something. Okay, so that's done. So we should be able to go to Thawny and run Blink. Or wait, can we just dude, Thawny is such an ass. What? Holy shit. Thawny is so shit. Nice. Sick. Okay. Okay, that wasn't actually that bad. You just have to remember to do this stupid... Okay, so you probably won't be able to see it. Oh, yeah, you can. Okay, so now we are going to attempt to port... We're going to attempt to control the stepper motor from the ESP. So this Pico... So wait, let me take a picture of the Pico. And then unplug it because this thing sucks. Well, it only sucks because I broke it. But I don't know how I broke it. $5 down the drain, man. Okay, so... Okay. Okay, so the problem is... Without a real pinout diagram, it's hard to know what anything is. No matter. Yeah, let's disconnect the regulator. I just want to do this with normal power. Okay. Um, okay, so like when it says D34, I really don't want an oscilloscope, so let me just use let me just use my okay. 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 So wait, what the fuck just happened? What? That makes no sense. It's floating? I don't understand. Okay, we have D23. All right, I'm going to write D23 to 1. So oh, fantastic. We reset. Okay, let's try to turn the Okay, that's good. Okay, it's at 3.3 volts. So then why is it that I have must have been doing something really weird. Yeah, why do I keep resetting this thing? I actually have no idea what's going on. Maybe that's something. I'm so confused. Okay, well, whatever, right? Whatever. Okay, so I should be good. And my code should be fine as long as I replace the pins. So let's close this. We don't need this anymore, I think. Or wait, let's okay. So we just need to change a bunch of pins, right? Okay. Okay, so let's just do one to start. So first off, we need our wire strippers and wire. It would be great to get this to work again. Especially with a new microcontroller, it would be nice. Okay. Okay, 3.3 volts logic is everywhere. So that's good. Now we just need to oh wait, can we just do a simple um oh, we are gonna need this thing. Okay. Bam. Wait, but we don't want to. Okay. All right. Let's just do this. All we need is this. Okay. I wonder if this works. It says Pico, but that's just. Okay, but now we need our power. All right, this is sort of the moment of truth for this part of the thing, because it very well could be that the second I turn on this power, I lose connection to the Pico because I fry it for some unholy, ungodly reason. I'm gonna actually unplug this. Just in case. Because who knows? Okay, so wait, let's just make sure that. I'm pretty sure that's all we need. Okay, so. Okay, so it is locked. That's a good sign. So, oh wait, so hold on, let's nice. Okay, cool. So, all right, so we can test our microstepping ability now. I'm gonna hook up the next one, so let's turn off the power. Okay. Let's switch this to 19 and 21. 19, 21, M2. Okay, and let's make sure we get this right. Now we just need to make some longer wires. That's definitely long enough. It's definitely long enough. Okay. Nope. No, it's not long enough. You gotta be kidding me. Yeah. And then green. Okay. So, all right. So we're ready for okay. Damn, these 4-pin things, they're just so loose. It's a little bit better. Nice. Okay. Um okay, cool. So let's freaking get on with it. Oh yeah. This is okay, so it works. Man, this thing has gotten really warped. That is pretty incredible. Why is it grinding so much? Holy sh! It is literally falling apart. That's insane. Yeah, you can't leave PLA out in the sun at all. What a joke. Okay, well, anyways, we got it working again. This time with an ESP. So that's great. I mean, that's actually great because now I am not so worried. No. Oh. Is that it? Cool. Yeah, I forgot the readme became a mess, but that's okay. All right, let's go get our parts. I forgot. I'm gonna need my phone because I need to counterbore the mounting holes so that I can assemble it. Actually, I'm going to use my drill press. I was going to use a screwdriver, but I'm going to use my drill press. I just need to bring these. I'll be back. Okay. All right. Finally done. First time using a drill press. Didn't go terrible. Didn't go great. So I only did 2 of them. Oh, and I forgot the other parts. That sucks. Okay, but in any case, let's disconnect this, disconnect this, disconnect this. Okay, let's put all this stuff away. Let's get this stuff going. Okay. All right. I should have made much longer wires, but it's okay. It's okay. All right. The first one. Okay. Get it in there. Okay. Get it in there. Fuck. Yeah. This is gonna break. Oh yeah. Oh my god, this part is such. This is so crappy. Okay, whatever. We have to send it. I mean, can you guys see this? This. What happened? Oh my god. What happened? These cameras, they just don't even do it. Okay. This thing doesn't even sit up straight because it's so. So we'll need to put it on a platform. Okay. Typical, typical, typical. Maybe I should go counterboard the other 2. Wait, this is number 2. Okay, yeah. This is number 2. Okay, so we're gonna put it like this, I guess, and then on something else, like this. Okay. Okay, so now we need to power the power supply. And we need to connect the Pico. Why didn't that make a sound? Have I not done it yet? Or maybe I'm muted. Okay, I think I'm good. Dual motors, 10%. Okay. Oh wait. We need to install the other things. I gotta get the other parts. Man, I'm all over the place. I'm all over the place. Okay. Cool. We need our M5s. And then the diameter of this, we probably want 12s. Okay. Okay. No, we need 16s. Okay. Okay. So first one goes on. There's absolutely no way to align this thing. What? I thought I gave a millimeter of play. Why is that? Why is that not? It's sagging. Okay, fine. I give up. I'm gonna go counterbore the rest of them because it clearly needs to be supported on both ends. It's just not gonna work. Countersink, counterbore. I don't know what it's called. Damn, bro. Damn, bro. You just got to think when this thing works, it's gonna be sick. And of course, the crimp connector broke. Ooh, you gotta be kidding me. Okay, I'll be back. Okay, I'll be back. Okay. Good shit. Son of a bitch. Okay. There we go. Okay. Cool. Hopefully that's enough. I want to try to scoop some out of there. Okay. Great. Fix the crimp connector. Fix the crimp connector. Why don't you fucking crimp this, bitch? Fucking crimp this shit. God damn. Okay. That's gonna be strong enough for now. Okay. We are ready. This is the first input, but whatever. We'll put it here. Okay. A tale as old as time. Forgetting to put in fasteners and then having to do a bunch of dumb nonsense to clean it up. Oh, is this thing on? Yeah. Okay. That thing's pretty on there. And the main problem is that stupid. I just didn't give myself enough clearance. Okay. Let's get the first one in. Like that. What? Oh, that's not right. Okay. Okay. Okay, wow, the counterbore actually does look really nice. You can hardly see them bulging out. Okay, so this one needs those two nuts. Okay. Holy shit, we're getting so close, man. It's been 8 hours. There was a couple of hours in there where I wasn't really doing anything cool. Oh, it's not all the way down in there. Okay. And come the hell? Why isn't this one going in? There we go. Okay. Cool. Is this thing locked? How's this thing locked? That's weird. I don't like that that's locked. Why is it locked? Whatever. Whatever. Presumably it's fine. I don't really get why it's locked, though. It's a little spooky. This one's fine. Okay. Yeah, that was weird. Okay. What if I... Okay. Certainly if I... If I unplug this... It won't be locked anymore. Whoa. What is doing that? Did I dig into the motor from this thing? Oh no. Oh no, bud. That is no good. It is very possible I just damaged this motor. What the hell? Why don't they tell you that? The stepper motors, it bottoms out, man. Bottoms out and you can't... Dude, these flies gotta get off of me. Now is not the time. I'm so close. That is wild. So let's just get a shorter M4 then. For that one, get an 8. Because that was sus. That was sussy baka. Baka! Bro, I am literally fucking brain dead. Okay. Baka! Have you no shame? Okay. Should I just do an M8 on there again? Okay. Okay. All right. Hell yeah, bruski. All right, so this is the moment, dude. This is the freaking moment. Okay, we just need to install the last melon. Back up. Okay. All right. We're going to turn on the power supply. We're going to see if we can spin these things up. Okay. We are pretty much ready. Oh, shit. Oh, one of those had the M5x16 and one of them had the M8s. Or sorry, the M4x8s and the M5x16s. Okay. All right. Jesus Christ. Wait, Pico disconnect. Pico is disconnected. Okay. Holy shit. Where's my Nerf rival round? Oh my god. Let's try to aim it at the camera. Not that camera. Well, okay. Let's see. Fuck it. Okay, so the first thing I clearly noticed is that. Okay, wait. This is at 10% speed. We're going to 100, baby. You gotta hold it down. Oh, it's stalled. We're about 50. Damn it. 20? Oh no. I could have blown it. Oh my gosh, it actually goes so fast. It actually goes so fast. Let's double it. We gotta double it. Let's see, can we get a good shot out of this thing? Damn. Oh shit. This thing is freaking badass. Here, I'm gonna get a shirt so I can make the clip. Should I try 30% power? I want to try 30%. See how far this thing will go. Okay, so let's make the clip. Let's figure out how I want to stage this. I really want to make it good. So, I want it to be like, today I designed and printed a, let's see. Today I designed and printed a flywheel-based, yeah. Should I just write out a script? That'd be easy. Today I built a flywheel-based projectile. Okay, yeah. Let me just do it. But I need this video Or actually, I don't need this video. I can just turn off this video. Make this full screen. Okay. Okay. All right. Let's see. Okay, at 8:15. Today, I created a flywheel mechanism that shoots Nerf rival rounds out of a DC motor. I can't play it back. I need to play it back though. That's probably good enough. I'm happy with this. Maybe let me make the last changes. Let me make the last changes on the fusion model. We're just going to increase the extrusion height so that it doesn't need to be on blocks. That's the most important thing. So the holder, this extrusion needs to be plus like 45. And then I'm also going to okay, that's it. I'm just going to do that. We'll print that. And then the only other thing is we need to draw a sketch on here, hide everything else, hide the motors. And over this, we need to draw a... Where are my calyps? My calyps! I think... Yeah, it's these. What the hell? Am I out of battery? Seven point one to 7.2. Okay. And then a line here. Oh, wait. A line here that, do we have this? Can we project this? Ugh. Seriously, bro? Okay, yeah, that's fine. Should take... Okay, then we mirror this. Okay, then we make a midpoint line here. This is construction. This is also construction. Then we take these two, and we just need to counterbore it by like 3.5, right? Okay, then we want to take... Wait, why is this circle even here? I don't care about this circle. I want this profile. I want this profile. I want this profile. And I want this profile. And I'm extruding them minus 3.5. Okay. So now we can save that and reprint it. It's going to be tall, but that'll be good. That'll be good. So yeah, this thing works great. I want to try 50% really bad. Or 40. Let's work up to it. This is so sick. Where's my Nerf round, bro? This thing is fucking awesome. Well, I have 50 more. Who cares? Okay. So I'm already seeing a bunch of issues. I think that these balls need to be slightly heavier or denser because air resistance is going to be a huge problem. They're too light. I wonder if I could just use a flywheel-based mechanism to shoot a paintball. I should just buy some biodegradable paintballs and see. And so that's why we need to make... So hold on. In the README, we need to... okay, so we did both of these. Wait, we want to put these at the end. Design an adjustable width flywheel projectile shooter. Yeah. So these were M4 by 12s. No, they're not. They're like by 10s. Well, I'm going to put them in here. It's going to be fine. Okay. Okay, so let's just print that out. Fixes. Save as mesh. Okay. Save, overwrite it. Okay, and we're just going to print it one more time. I can't even tell. Oh, yeah, it does. Okay. Yeah, it should be fine. Okay. I feel like in that video you can't tell. Let's try this. Focus on this. Focus on this. Okay. Okay. So let's run it. I've already lost 2 of my rounds. Whatever. All right. Okay. I have to get my face in it. So let's see. Today I designed this flywheel projectile shooter. How am I going to do this? I need to control with my phone, man. All right, let's do that. Or actually, why don't I? Oops. I'm gonna move this. Okay. Can I make this work? I feel like I need to be in the frame. Why don't I? Do this. Yes, we got. Okay, so why don't I? I'd say we just keep it running, maybe. Let's see what the gain is like when it's running. Today I designed this. Hold on. Today I designed this flywheel-based projectile mechanism. It's not that cool. We need to angle it up. How can I angle it up? We need to put something under it. I don't want it to fall off. All right, that's enough. I'll find a clip in there somewhere. All right, that was a very successful day. Yeah, the air resistance is too high, though. All right, peace.